Hello guys. Welcome to our first session on MySQL. Uh, I am Nishan Gupta and we are Yash Infotech, and this is our first video on the MySQL. Okay. So SQL is a standard query language that was developed by IBM in 1970s. Uh, there are five major segments in SQL: create, insert, update, delete, select. These are the five major segments or parts of the SQL. And we need to know them in this order only. First, we need to know how to create databases, how to create database objects, how to insert data in that, how to update the database objects, how to delete them, and then at last we will be learning how we can fetch the data from these database objects. Yeah. Okay. So uh, this SQL language can be divided into further sub languages. Uh, Sub languages are DDL, data definition language. Yeah. One second. I'll take you through that also. DDL, data definition language. The examples of data definition language are create, alter, rename, truncate, and drop. We'll be discussing in detail about these functions. But just for an overview, I'm just giving you an overview of the sub languages of SQL. Then we have data manipulation language, DML. Insert, update, delete are the part of it. Then we have data query language, DQL. Select is the part of that. Transactional control language, commit, rollback, and save point are part of that. Data control language, grant and revoke are part of it. Yeah. Then we have moving forward with that, we will start with the data definition language, and we'll be starting with the create part of that first. So let's first create the DB, and let's start our job on the editor. So our editor for writing the SQL database, or SQL, creating SQL database and SQL objects, is MySQL Workbench. This is our editor. So we will be using this MySQL Workbench for our query creation and running part and database creation part. Okay. And it is freely available on the Microsoft, as you can search on the Google as Microsoft MySQL Workbench. It will be available without any cost. You can download it and create your test connection, and you can create your DB like this. Okay. So to create the DB, syntax is create database, then test underscore DB is the database name. This is the database name. Okay. So when I execute this particular part of the code, you can see here create DB, one row effective. It means it is successfully run, and we can see the green tick over here. So this line which I just selected and use this key, this function, this button to execute this statement, and only this statement got executed, and the database with the name test underscore DB has been created. How we can see that? So in the schemas here in the navigation panel in the left side, we will just refresh the existing schema. Okay. Now after refreshing it, see, I can see here test DB, which has been created. If I see the tables, there are no tables because there is no drop down coming over here. No views, no store procedures or functions currently present here. Uh, we will later on also create the tables and everything. So we will be discussing that also in detail. Okay. Now, since there are multiple, DBs created like data practice, fastcart, SQL, something, sys, and test underscore DB. So if I want to use any one particular DB at a time, then I have to use this particular keyword, use database name. For me, I want to use test underscore DB, which we have just created. So I would run this statement now. So how I can run it? I will just select it uh, and run it. Okay. Okay. So you can see now here, uh, right, green color tick, use db test underscore db, 0 rows affected. So it says that no rows are affected, but this query has run successfully. Every SQL statement should end with a, you have noticed that I have written semicolon every time we are running a query. So every SQL statement must end with a semicolon. If we do not write the semicolon, then it might throw error when you know there are multiple lines, then it might throw errors. For example, I am selecting these two lines together. First is having the semicolon, the second one is not having the semicolon. Okay. Or we can do vice versa, that first one doesn't have the semicolon and second one have the semicolon. And if I try to run it now, see the error in the SQL syntax. So if you are running multiple SQL statements, each and every SQL statement must end with a semicolon. Okay. Now this statement over here, drop database test underscore DB, it will delete the database that you have already created permanently from the schema. So if I run this, I execute it. See, it has been executed successfully. We can see here. And if I refresh it, I can't see test underscore DB over here. See, it has been deleted. Okay. So this is the use of drop keyword. The syntax is very much simple. Drop, then database, then database name. Okay. Now I will be again creating it. Create database. Okay. It has been created. Then I would use it also. So it has been successfully run. If you want to see the name over here, you just have to refresh it. You can see test DB. Until now, no views, tables, anything has not been created. Okay, let's move forward. So we have single line comment in the next part. So single line comment is nothing but if you are you are writing a script, big script for the SQL, and big script has many sections. So it is for the helping the developer to understand that this part of code is written for which uh, what is the reason of writing that code. So for that we write comments in that, and we can write comments for our for the ease of developer. So these comments can be written from two dashes. Okay, if I remove these two dash, it will be in a different color and it will be not considered as a comment. In fact, it will try to consider as a syntax of SQL code. And since it is not written in a right syntax, so that's why it is throwing error over here. But if I want this to be written as it is and it should not throw any error, then I can comment it. And if there is only single line, then we use two dashes and space, and then that line gets whatever anything which is written after that will get commented. So if you write star 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 star, whatever you write, it will not affect the code. It will be considered as a comment. Okay. Similarly, if you have multiple lines, like a group of lines, 10, 12, 15, whatsoever, so those can be commented with a backslash star and then star and backslash at the end. So like this, we can see here. Okay. Okay. So since we have covered all this DDL, DML, transaction control, everything, we will be starting with the process of creating the tables. So a table is nothing but a group of columns and rows. Okay. So to create any table, we have to follow this particular syntax. We have to write the create keyword, then table we have to write table keyword, then this is the table name, which is persons, persons, persons. And then we have to write all the columns that should be there in that particular table. So first column is ID, which is of integer data type. Then data type, as you, if you are from a coding background, then you must be aware about that every variable that is going to store a data must have a data type, that it is storing a integer data or a boolean data or a float data. So for those purposes, these data types are. So currently you can see that ID is of integer data type and it is also the primary key. So primary key is a constraint. Constraint means you can put constraints on the columns of a table. There are some conditions uh, that these columns have to follow. So whenever after the data type a keyword primary key is written for any column of a table, it means that that particular column cannot have null values. One, cannot have duplicate values, means if some person has ID 1 and I have inserted that record already, and if I want to insert that ID 1 again into that column, it will not allow us to insert and it will throw an error that primary key constraint violated, like that. Yeah. Then we have last name column, which is of varchar data type. So varchar is nothing but your variable character. 255 is the length. So and you can write a last name of length 255 alphabets in this. Okay. And then first name, that is also of varchar, and then we have age, which is again integer data type. Okay. Not null constraint is available for both of them, last name and first name. It means that the null values can't be stored in the last name column as well as in the first name column. But here you can see that there is no null constraint or any other constraint on the uh, um, age column. So it can get store values, null values also as per this current structure of the table. So I'll be just selecting this and executing it. See, the table has been created, successfully executed. Zero rows affected because there is no data inserted or retrieved. So that's why it is coming like zero rows affected, but the table has been created. So if you just refresh here now, you can see a drop down is coming in the tables column section. And if you can see the tables persons has been created. We have written the person name here only. So we can see it here. Okay. Now, to see the records present in that table, we just have to write a select keyword and then a star means all the columns from, then test underscore DB is the database name and person is the table name, and then a semicolon at the end as always. If I execute it this way, it will give me all the data which is currently present in the persons table. Currently, there is no data present, only the column headers are present. So that is how it is coming. Once we will insert the data, all the data will come up from this statement. Okay. And describe DESC, test underscore DB is the database name, persons is the table name. So if I execute this one, it will give us the field type. It will give us the description about the table structure of person. Yeah, everything, data type, it is not null constraint is valid or not. And so see, for all the three starting three columns, ID, last name, first name, not null constraint, you cannot enter null values, but in the last age column we can enter the null values. It shows like that. As we know that already in this particular statement we have written primary key for ID, so that's what it is written, primary key for ID. Yeah. So all this information is available in the describe keyword. Okay. If we execute this statement, drop table db test underscore db dot persons, so it will delete this structure of the table, and this table will get structure of the table will get deleted. So I'm just selecting it and executing. The statement has been executed successfully. And if I run this select start from persons, now we will get an error that the test underscore db person does not exist. Since we have dropped that table, so this table now does not exist. Okay. Uh, Now, whew, Let's move on to the next part of this. So let's again first create this. Let me execute it. Okay. Zero rows affected. If I run this, it will be coming up. Okay, great. Now, in this, now suppose I have already created the complete structure. But now after creating the table structure, I want to amend in the column age. And I want this column to make it as also not null constraint. I want to add that not null constraint on this particular column as well. So what I have to do is I can use the alter table syntax, alter table, then table name, modify column, then column name, then int is the data type, and not null is the constraint I want to add. So you have to follow this syntax if we want to modify the constraint over any particular column or data type of any particular column. If I select this much part and I execute it, so this one gets executed very successfully. And if now I see the structure of the person's table, if I run this one, we'll be able to see that yes, for age also we can see no. So it cannot accept the null values now, the age column. Earlier it was yes here. Okay, moving forward. There are different ways to create the table. Earlier you can see that the id column was created as primary key, but I don't want to create it as a primary key, so I can also write not null constraint for this. And I can but I also want that it doesn't accept the null values and it doesn't accept the duplicate values. So for that reason, I can create it as unique constraint. So for that we have to just write unique, and in the brackets you can write ID or the whatever column name for which you want to make it as unique. You know, the idea behind this is the what it does it that all the values that we'll be storing inside ID column will be unique only. It will not have the duplicate values. In this way, we can create. This is a different way of creating the table. Uh, Slightly different syntax, but the end result will be the same. It will create the table at the end. Yeah. Then uh, the same thing you can write it in a different way. For example, you have taken ID not null, varchar, everything is there, in age is integer. Then you can write constraint UC persons is the constraint name, and then unique is the constraint keyword, and then you want the column of these two combinations to be unique, like ID and last name. Combination of these two column value inside these two columns should be unique and should not be duplicated. But inside ID, you can duplicate. Inside last name, you can duplicate, but the combination should not be duplicate. So that's what you have to make sure. So these, so we can create unique constraint using multiple columns as well. This is what I wanted to explain here. Okay. Suppose if I run this, person 3 is the table name, remember. Okay. This has been successfully created, and I will just write the ESC person 3 and semicolon. Let's see what happens. Persons. Okay, I made a mistake. I just have to write S over here. Okay, let me run it again. Here it is. See, so ID and last name combination is unique now. Okay, for this combination, it is showing as PRI key. Okay, let's move further. Now, earlier in the first person table which that we created, we would have written after integer we have written primary key. That was one way of writing the syntax. In this way also we can create the primary key id column as primary key in this way. Okay, we can write primary key and then brackets we can write the column name whichever we want it to be. you know this is another way. Then this was already we have done. Okay, then okay, this is another way. write constraint, constraint name, primary key, and it is column, combination of these two column. Now, okay, let's. So, there must be a question in your mind that what is the difference between primary key and unique key? So basically, primary key also doesn't allow duplicate value. Primary key also doesn't allow null value. Unique key also doesn't allow duplicate value. Unique key also doesn't allow null values. But there can be multiple unique keys created in a table. We can create multiple unique keys, but only one primary key we can create. For example, if I have created this pk underscore person as one primary key, which has two columns or n number of columns it can have, but only one primary key can be created. And but we can create multiple unique keys. We can have two column, for these two columns one unique key, and for the remaining two columns one more unique key, like that. So we can have multiple unique keys, but primary key is only one in a particular table. Okay. Then you can see this time we have also created foreign key. Now, the foreign key concept, this is the syntax to be create. In this way, we can create the foreign key. But this is a different table. Earlier, we were creating person tables. Now, this is a order table which has different columns like order ID, order number, person ID is one more column. Now we are saying in this that primary key is the order ID for this particular table, but person ID for this particular table is the foreign key, and it references to the ID column of the person table, which we have already created. This person table ID column is being referred over here, and uh, this column person ID has been created as the foreign key for the orders. So it means that whatever values which are present in the ID column of person table, all those values will be present in the ID person ID column of the order table as well. Okay. So if I execute this statement and I run it, zero rows affected, this table has been created. If you want to see these tables here, I'll just refresh the schema, and tables, orders, persons, person three, all these tables, whichever statement we run, are all created over here. Okay. Then there are different ways to write the foreign key syntax. One is this one, and the other way is constraint, then the constraint name, foreign key, then column references the same way. Slight difference in these two syntaxes, both are applicable. Okay. We can have check constraints also. For example, we have written this check age greater than equal to 18. So it means that any record, if the age is less than 18, that is 17 or 15 or 12 or 10 or 11, then those records will not be inserted in this particular table. It will throw error if you are entering those records where the age is less than 18. It will throw error in, and those records will not get inserted if this check constraint is available on that table. That is what. Okay. So in this way, we can write that. That's fine. Then we can write the check constraint on multiple columns as well. So age is uh, greater than 18, and city Senden, said Sandness is the city name. If these two things are there, then only then the records will get inserted. If the person is from any other city and the age is less than 17, so it will not get inserted. Less than 18, so it will not get. Even if the age is greater than 18, but the city is different, then also it will not get inserted. These two conditions needs to be true in order to get that data inserted into this particular table. So these are the checks. Okay. Then we can also create the indexes as well. So syntax for that is create index name on table name column 1 to whatever columns you want to create the index on. So for example, if I want to create index, so create index name on persons, and in bracket I will write the name of the column on which I'm on to create that index. In this manner, we can create the index. Okay. Like this, if I executed this and it is successfully created. Okay. Now you need to make sure what is the use of index. So indexes are used to retrieve data from the database more quickly than otherwise. Okay. The users cannot see the indexes. They are just used to speed up searches and queries. So basically, users cannot see the indexes. When you run the select star from that particular table, you will not able to see that which column is having the index. But if you have an idea that, okay, I have put index on the last name column, and if I search in that particular table using the last name column, then I will get the results quickly. Okay, more quickly than compared to the other column or other conditions on other columns. When you update the table with indexes, it takes more time in updating with a table without the indexes, because indexes also need to get updated. So only create indexes on columns that will be frequently searched against. So that's what it is. So while creating index, we need to make sure that which is the right column, which will be searched more. We should only create index on those particular columns. Ideally, it should be any ID, like a person ID. It should be taken as the index. So yeah, okay. Then I guess this auto increment is also there. So this function auto increment, if we write auto increment like this, it means that the person IDs will get automatically incremented along with the records. We doesn't have to insert it from our side. It will get in automatically incremented. For example, it will start with 1, then 2, then 3, then 4. Along with the other records, it will get automatically incremented. So we doesn't have to, while inserting the data, we doesn't have to insert the person ID in that. Okay. Now to insert records in those tables, we have this syntax, and I think we will be covering this insert into in the next lecture. Thank you. Stay tuned.